Hello everyone, my name is Kishan Agarwal. Today I am going to present my AAT Tech Talk video of programming with objects, and my topic is how to program machine learning in Java with Tribuo library. So let's begin with a question. What is machine learning? Machine learning is a field of inquiry devoted to understanding and building methods that learn. That is, methods that leverages data to improve performances on some set of tasks. Has been a part of artificial intelligence. Machine learning algorithms build a model based on sample data, knowing training data, in order to make predictions or decisions without being explicitly programmed to do so. Machine learning algorithms are used in a wide variety of applications, such as in medicine, email filtering, speeches recognition, agriculture, and computer vision, where it is difficult or unfeasible to develop conventional algorithms to develop or to perform the needed tasks. A subset of machine learning is closely related to computational statistics, which focuses on making predictions using computers, but not all machine learning is statistical learning. The study of mathematical optimization delivers methods, theory, and application domains to the field of machine learning. Data mining is also related field of study, focusing on exploratory data analysis through unsupervised learning. So let us see some of the applications of machine learning. So this is what I have explained: machine learning, which have reinforcement learning, supervised learning, and unsupervised learning. So unsupervised learning means dimensionality reduction, clustering, whereas supervised learning is further classification and regression. Reinforcement learning, like real-time decisions, robot navigations, learning tasks, skill acquisition, games, AI, etc. So unsupervised learning, in that clustering considers recommender systems, targeted marketing, customer segmentations, whereas dimensional reductions are structure discovery, feature allocation, big data visualization, meaningful compressions. Next is classification: image classification, identity fraud detection, customer retention, diagnostics and regression, advertising popularity prediction, weather forecasting, market forecasting, estimated life expectancy, population growth prediction. So this all comes under machine learning. These are, or we can say that, applications of machine learning. So some of the specific applications of machine learning are, see, machine learning is a buzzword for today's technology that is growing very rapidly day by day. We are using machine learning in our daily life even without knowing it, such as Google Maps, Google Assistant, Alexa, etc. These all are machine learning applications. So this figure shows some of the applications of machine learning. They are image recognition. First is image recognition. Recognition is one of the most common application of machine learning. It is used to identify objects, persons, places, digital images, etc. The popular use case of image recognition and face detection is automated friend tagging suggestion. Facebook also provides this feature to auto detect your friend tagging suggestions, and many applications are there further for image recognition. Next is speech recognition. Speech recognition, while using Google, we get an option of search by voice. It comes under speech recognition, and it's a popular application of machine learning. Traffic prediction: if we want to visit a new place, we take help of Google Maps, which shows us the correct path with the shortest route and also predicts the traffic conditions. So it predicts the traffic conditions such as whether traffic is cleared or slow moving or heavily congested with the help of two ways. First is real-time location, that is the real-time location of vehicles from Google Maps and sensors. Next is average time has taken on past days at the same time. So this helps in traffic prediction. Next application is product recommendations. Machine learning is widely used in various e-commerce and entertainment companies such as Amazon, Netflix, Flipkart, etc. for production product recommendations to the user. Whenever we search for a certain product on Amazon or Flipkart, then we start getting an advertisement for the same product while the internet surfing on the same browser, and this is because of machine learning. So Google understands the user's interest using various machine learning algorithms and suggests the products as per the customer's interest. Next is self-driving cars. One of the most exciting application of machine learning is self-driving cars. Machine learning plays a significant role in self-driving cars, like Tesla, the most popular car manufacturing company, is working on self-driving car. It is used using unsupervised learning method to train the car models and also to detect people and objects while driving. Next is email spam and malware filtering. Whenever we receive a new email, it is filtered automatically as important, normal, or spam. We always receive an important mail in our inbox with the important symbol, and spam emails in our spam box. And the technology behind this is machine learning. Below are content filter, header filter, general blacklist filter, rules based filters, and permission filters helps Gmail to filter the spam filters and malware filtering. Next is virtual personal assistant. We have various virtual personal assistants such as Google Assistant, Alexa, Cortana, Siri. As the name suggests, they have us to finding the information using the our voice instruction. So these assistants can help us in various ways just by our voice instruction, such as we say like play music or call someone or open someone's mail, scheduling an appointment, etc. Next is online fraud detection. Machine learning is making our online transactions safe and secure by detecting fraud transactions. Whenever we perform some online transactions, there may be various ways that our fraudulent transaction can take place, such as fake account, fake IDs, and steal money in the middle of a transaction. So to detect this feed, such as fake feed, forward neutral network helps us checking whether it is genuine transaction or a fraud transaction. Next application is stock marketing trading. Machine learning is widely used in stock market trading. In the stock market, there is always a risk of up and down in shares. So for this, machine learning long short-term memory neutral network is used for the prediction of the stock market trends. For medical diagnosis, it is also useful in medical science. That is, machine learning is used for disease diagnosis. With this, medical technology is growing very fast and able to build 3D models that can predict the exact position of different parts of the body. Next is automated language translation. This is very helpful device. Nowadays, if we want to visit a new place and we are not aware of the language they speak, so machine learning helps us by converting the text into our language. Google's networking machine translation provides this feature, which is a neutral machine language that translates the text into our familiar languages, and it is called as auto translation. So these were the few applications of machine learning, and many more applications are there. Now we'll jump into our topic. So there is a small topic called deep learning. One popular subfield of machine learning is known as deep learning, which is concerned with taking raw data inputs and automatically learn multiple layers of features, each more refined than the last, before making the final prediction. So deep learning powers the image recognition system inside smartphone cameras and speech recognition systems inside personal assistants such as Alexa, Siri, and Google Assistant, among many other use cases. So deep learning is a subset of machine learning. So this is okay how this work and all. What are the applications of machine learning we have discussed. Now how does the software interact with models? So conceptually, you can think of most machine learning models as functions that accept an array or multidimensional array of floats and produces a number that is an array of numbers. The input array are the features like pixel in image, values from a database, table ID numbers representing words in a sentence, and so on. The output values can be cluster IDs, class label IDs, floating point outputs for regression tasks, or other number of types, numeric types. This view of world is mathematically unsuitable for the MATLAB programs that find many machine learning algorithms were first implemented in. Introducing Tribuo. Tribuo is a new open source library written in Java from Oracle's Lab Machine Learning Research Group. It has been inside Oracle in production for several years, and Oracle open sourced it in September 2020 on GitHub. So the team goal for Tribuo is to build a machine learning library from Java platform that is more in line with the needs of large software system. Tribuo operates on objects, non-primitive arrays. Tribuo's models are self-describing and reproducibly, and it provides a uniform interface over many kind of prediction tasks. For in addition to the type system enforcing things at the object level, each Tribuo model contains its own feature and output domain. You can inspect them, discover whatever features you know about. Next is Tribuo's enterprise friendly focus and provenance system. So building machine learning system to solve enterprise problems give Tribuo a different focus than that of many other libraries in different languages. Enterprises usually operate on database tables and text. Consequently, Tribuo assumes all the feature spaces it is operating in are space, and any other features that are missing implicitly zero. This sparsity is useful both in natural languages processing tasks because each document contains only a subset of possible words features, and in more general enterprise tasks where features based on join between different tables are conditionally extracted. One final area where Tribuo is very different from other machine learning is provenance systems. Next, why Tribuo was built in Java? Why not in other languages? So Oracle has invested heavily in Java, and as a part of Oracle's Labs mission to transfer new technologies into Oracle's products, the Tribuo team has been working on machine learning on the JVM for some time. The team thought that instead of integrating dynamic languages into Java application stack, it would be simpler bring the power of machine learning to Java developers where they are, that is on the JVM. That's why developer can take an advantage of large library ecosystem for non-machine learning tasks such as loading data from databases or responding to a web request. Leverages the high performance JIT compilers available for the JVM to accelerate code without writing everything in a low level language and easily integrate with their applications. The language with the large machine learning library ecosystem tend to be harder to build large applications in due to the lack of static typing and compiler checking. Working with teams building products in Java exposed a need for a good single mode machine learning library on the Java platform that could be used as a basis of building machine learning product features. So Tribuo was built in Java. So now using Tribuo. Tribuo's type system starts with the output interface. The implementation of the class are the values that can be predicted by a Tribuo model, and many of the Tribuo's classes are parameterized by the type of output they operate on. So each output subclass has a family of support classes, each of which subclasses one of these interfaces. Output info tracks the domain of the output, such as the possible values and the number of times those values occurred. Evaluator produces an evaluation measuring the performance of the supplied model on the supplied data. Output factory manufactures outputs of the right type from strings along with the sentine unknown output and the right version of the both output info and evaluator from its output subclass. So in Tribuo, the data loading procedure starts with a data source. This is a type based on the prediction type that's going to be used, which in this case is label. Data source is an iterable and also provides methods for computing the data provenance and an accessor for the output factory. Instance Tribuo's examples are tuples of an output instance representing the ground truth for this data point or the unknown output if it's not known, and an array of feature object. Each feature is a tuple of feature named string and a double for feature value. Data source perform the initial ETL step of getting data off disk out of the database and into example features. This step is also known as featureization. Tribuo provides plenty of data sources for different data formats and also extensive columnar input processing packages. So this code leads in the MNIST training set from the canonical files, creating an example for each image that uses non-zero pixels as feature. Because Tribuo's representations are implicitly sparse and the label instance representing which digit it is. Tribuo produces logging output during model training, allowing prediction centers has overload of the batch prediction, accepting iterables. There are also accessors from the domain, provinces, and a few other model specific field, but those are familiar, straightforward. Next is making the run and evaluating model. So a prediction contains three main elements: the predicted output, an optional set of other outputs, and score, and a reference to the example that produced it. Prediction also contains a boolean denoting whether the scores are probabilities, the number of features present in the example, and the number of features that the model used to make the prediction. The later information is used for evaluating how a model behaved, and if it understood the supplied features. This information tends to most helpful when you are working on NLP tasks because it shows how many of the words in an example exist in model's vocabulary. Each output type has its own evaluator and evaluation subclasses. An evaluator is a factory that produces evaluations when supplied with models and test data or predictions. Each evaluator computes a specific set of performances, metrics, and the appropriate averages. An evaluation contains all computed performance metrics along with the sufficient statistics to compute other metric if desired. Next, coming to integrating Tribuo into machine learning environment or ecosystem. While some might like to think that all computation happens in Java or JVM, at the moment most machine learning models are trained on other platforms such as Python using libraries mentioned like SciPy, etc. It's very common for data scientists to explore their problems and train models to solve them in Python. Yet, when it comes to putting those models into production, they need to integrate the models into a Java system. This is the cause of many issues when machine learning systems are deployed because the Java versions of models may be use different libraries and different input processing steps, and they may produce different outputs. Tribuo and the Java platform. Tribuo is written entirely in Java, though there are a couple of dependencies that contains native code. It currently targets Java 8 and it's tested on long-term support versions of Java along with the latest release. So we have discussed Tribuo library, talked about the design choices inherent to in building machine learning libraries, applications of machine learning, what is machine learning, and deep learning, which is a part of or a sub part of machine learning, and discussed integrating Tribuo into a wider machine learning workflow, and also briefly discussed about new Java features that are incubating or in a preview could be used to accelerate the performance of numerical code such as Tribuo and other machine learning libraries running on the JVM. Thank you.